Hi everybody, I'm making a video here on problems number 15 through 22 from your Chapter 5 study guide, which are the exponent property problems. Problem 15 is where I'm going to start. You'll notice that there is a set of parentheses where everything is raised to the negative third power. There are a couple different ways that I can handle this. I'm actually going to handle it a different way in problem 16. But in this problem, what I am going to do is I'm going to apply that power down to each item inside the parentheses. H to the negative third, x to the positive sixth, and y to the negative 9. If you need a reminder what I'm doing there, I'm taking negative 2 and multiplying it by negative 3 to get positive 6, or 3 times negative 3 to get negative 9. When you raise a power to a power, you multiply. Now, anything with a negative exponent is going to go in the denominator. Anything with a positive exponent is going to stay in the numerator. That is my final answer. I would rather have you give me 8 cubed than tell me what 8 times 8 times 8 is. If you need more help on these problems, feel free to check out the other videos I have recorded on this that go into way more depth in way more time. All right. Now, problem 16, I see a fraction raised to a negative exponent. Anytime I raise a fraction to a negative exponent, I can take that fraction's reciprocal and raise it to the positive version of that exponent. Now, before I actually go about doing that, I'm going to reduce what I have inside the parentheses. So I'm going to reduce this to 2 over 1 x cubed and z squared. Doing that actually completely gets rid of the denominator. It's 2 because 4 over 2 is 2. It is x cubed because x over x to the negative 2. I'm finding the difference between those. Difference between 1 and negative 2 is 3. And if I have 3 z's on top and 1 on the bottom, one of them cancels out. Now I'm going to take that 2, I'm going to apply it down just like I did in problem 15. I'm going to get 2 squared times x to the 6th times z to the 4th. Final answer. All right, in problem 17, I'm going to look again at my numbers first. Then I'm going to look at my x's. Then I'm going to look at my y's. So the numbers, I see I have 3 times 25. That would make 75. In the denominator, I have 15 times 5, which is also 75. So that's going to reduce to 1, and my final answer won't have any visible numbers in it. All right, then I'm going to count my x's. In the numerators, total, I have 3 x's, right here, x cubed. In the denominators total, I have 6 x's. 3 x's in the numerator, 6 x's in the denominator. That is going to reduce to 3 x's in the denominator. There are 3 more in the denominator than in the numerator. All right, finally, the y's. I see that I have 7 and 2, making y to the 9th in the numerator, and y cubed in the denominator. That's going to reduce to y to the 6th. So, final answer for that one, y to the 6th over x cubed. All right. Problem 18, similar stuff here. 2 over 6 reduces to 1 over 3. X cubed over x squared. Remember, in a fraction, you can subtract exponents. That's going to give me x to the 1st. And y to the 7th over y to the 5th. Subtracting 7 minus 5, I get y squared. The normal way to write this would be xy squared over 3. Final answer. All right, moving on. Next 4 problems. All right, common mistake in problem number 18 is to forget that that negative 3 is not applying to the 2. If it was, the 2 would be in parentheses, and it most certainly isn't. So I'm going to apply from the inside out. This part right here is just going to give me x to the negative 6th, y to the negative 3. I'm going to take 2 times that, and then I'm going to square it all. Now, 2 times x to the negative 6th, y to the negative 3 is the same thing as 2 over x to the positive 6th, y to the positive 3. Those negative exponents, throw them into the denominator. The last thing I have to do here is I have to square, so I get 4 over x to the 12th, y to the 6th. I know I'm going really quickly here, so what you might want to do is you might want to check out some of the other exponent property videos I have. Oh, problem 20, answer is number 1. I'll get to that in a second. Problem 19, I have to do the numerator first because I have an exponent which has to come before this fraction, which is division. So the numerator becomes x to the 6th, y to the 6th, z to the 12th. Denominator becomes x to the 8th, y to the negative 3rd, z to the 6th. So remember, I'm thinking about these completely independently. I'm thinking about the x's, I'm thinking about the y's, and then I'm thinking about the z's, not all together. So I ask myself, are there more x's on the top or on the bottom? On the bottom, how many more? 2. So I get a denominator of x squared. Are there more z's on the top or on the bottom? There are more y's on the top or on the bottom. There are more y's on the top. So I'm going to ask myself, how many more are there? There are 9 more. From positive 6 to negative 3, you would have to subtract 9. So 9 y's in the numerator. And how many z's are on top? 12. That is 6 more than the number of z's on the bottom, so we get z to the 6th. All right, I know you've been waiting in agony to figure out why 20 is 1. Anything, any stuff whatsoever, no matter what it is, anything raised to the 0 power is 1. Except 0. You might want to ask a college professor or something. Go find another video on YouTube about that. They're all over the place. All right, 21. I need to actually do each set of parentheses here first before I can multiply or divide. So it's actually like problem 19, but a little bit more complicated. All right, so this top left set of parentheses is going to become x cubed, y cubed, z to the 6th. The top right set of parentheses is going to become x squared, y to the 6th, z squared. And the denominator is going to become x to the 12th, y cubed, z cubed. All right, I'm asking myself all the same questions about how many x's are on top, how many x's are on bottom, just like I did in problem number 19, except there's a little bit more complication here. I have 5 x's on top, 1, 2, 3, 1, 2. Then I've got 12 on the bottom. So 5 on the top, 12 on the bottom. I'm going to end up with 7 x's on the bottom. I'm writing 1 over 7 for now in case nothing ends up in the numerator. Not sure yet. How many y's do I have on top? I have 1, 2, 3, 1, 2, 3, 4, 5, 6. That makes 9 y's total. But I've got 3 y's in the denominator, so that's going to take me from having 9 to having 6. All right, and finally, I've got 6 z's and 2 more z's, or 8 total z's in the numerator. 3 z's in the denominator. That's going to give me z to the 5th in the numerator. All right, so those are the exponent property problems. I know they were super fast, so please feel free to ask me a question or check out some of the earlier videos on that. All right, see ya.